Okay, we can start now. If anyone misses, then they can watch on the YouTube because all this video will be uploaded on YouTube and the link will be given in the NPTEL portal. So, good evening, everyone. I'm Abhishek Thakur, Prime Minister Research Fellow at IIT Hyderabad. So, today we are going to discuss about the tutorial session on week 2 lecture of Principle of Signal and System taught by Adi Jagannatham sir. So, before moving on to uh, how we will go on, first we will see the concepts, then we'll solve some of the question that is very important related to gate examination, and also if you solve those questions then it will be helpful in your semester examination too. First we'll see what is the definition of system. System is something which maps the relation between input and output. So let's suppose this is our system. So whatever input we give here, a system will produce a output. So basically, it maps the relationship between input and output by process of transformation. So let's suppose input here is given is xt and output produced is yt. So yt will be transformation of xt. And this transformation is done by our system here. So this is the basic definition of system. If you want to write, then you can write it also. It is an operator which maps the relation between input signal and output signal by some mechanism of transformation. So system can be discrete time and continuous time. So for continuous time, here it will be T. For discrete time, we can write it as when we give the input xn, we will get output as yn. First, we'll discuss little conceptual like definition and theory of this, and after that, we'll solve lots of questions that will be helpful according to the GATE examination. So we will see today different types of system. So there are different types of system like linear system, non-linear system, and then time variant, time invariant, causal, non-causal system, static, dynamic. There are different kinds of system. So we'll see each one of them today. So the topic is classifications of system. If you have any doubt, then you can unmute yourself in middle and you can ask, or you can also comment in the chat box. Okay. So the first we will see that is linear and non-linear system. Second is time invariant and time variant. And there can be combination of these two also, like LTI system, that is linear time invariant system. This is very, very important according to the like GATE examination or any other competition. Third is causal system and non-causal. Static and dynamic system. We'll see the definition of each one of them. Stable and unstable system. and one more is invertible and non-invertible system. So the system is classified on these basis. So first we will see today linear and non-linear system, and we'll see what is the property of this. Okay. So the first one is linear and non-linear system. A system is said to be linear if it satisfies the two properties. First is additivity and second is homogeneous. So let's write this. A system is said to be linear if it satisfies two properties. First, that is additivity. In additivity, what happens? Like, let's suppose if an input x1t produces given to a system S and it produces output y1t, okay? And another input x2t given to the same system S and produces output y2t. So when you add this in input like x1t plus x2t when together given to a system S, then if it produces y1t plus y2t, then it is following the additivity property. Okay, any doubt in this? If x1t produces y1t and x2t produces y2t, and after that if we give the input x1t plus x2t, then it should give the output as y1t plus y2t. We will see various number of examples also after this. This was for the continuous time. In discrete time system also, like this was for continuous time, we can see for discrete time as well. Because nowadays in examination, question based on discrete time comes more than the continuous time because all the question on continuous time is now little bit easier. That's why. So when x1n is given to a system S, if it gives the output y1n, it is same only, and x2n given to that system gives the output as y2n. Then when the input is given as x1n plus x2n to that system, what will be the output? Y1n plus y2n. So this is the additivity property of linear system. Second is homogeneity. In homogeneity, it states that like if an input is scaled by some scalar factor that is c, then output is also scaled by the same factor. So let's see here. When we give x1t as an input to a system, we will get output as y1t. Now, if the input is scaled by some constant value that is c, then our output will be also scaled by the same factor that is cy1t. Okay. If x1t produces output y1t, then cx1t will produce output cy1t. So for a system to be linear, it should satisfy two properties. First, additivity. Second, homogeneity. Understood? Any doubt in this? You can also write for discrete time, like this was for continuous time. You can write it for discrete time, like when x1n is given to a system. If x1n is given to a system, it gives the output y1n. Then C of x1n will produce output C of y1n. So when you combine both the additivity and homogeneity, then what it will be? Like, see here, x1t plus y1, x1t plus x2t is given to a system S, then it will produce the output y1t plus y2t. This was the additivity property. Now when we will scale x1 by a, then output also it will scaled by a. If we scale x2 by b, then output also y2 will be scaled by b. So this is just the combined case in the continuous time signal. Then this is known as linear system. Okay. So now we'll solve some examples. Like I will give you the question. You can first solve. If you cannot solve, then I will solve here in the classroom. So most of the question will be from the previous year GATE questions only. We'll start with easy question first. Which one of the following is the correct option? The system characterized by the equation yt is equal to axt plus b is. There are four options. Option A is linear for any value of b. Option B, linear if b is greater than 0. Option C, linear if b is less than 0. And option D, non-linear. So in this question, it is given yt is equal to axt plus b. Now it is asking whether if the system is linear or non-linear. If it is linear, then for what value of b it is linear? So very simple question. Can you please answer which option is correct? Or let's see how to solve such kind of question. So here it is given yt is equal to axt plus b. Okay. Now to check whether the system is linear or non-linear, let's suppose take the input as xt is equal to x1t plus x2t. Then our output yt is equal to, we'll substitute this into in the first equation, that is axt plus b. So here yt is equal to a. We have taken xt is equal to x1t plus x2t. So we'll keep this here plus b. So this will be ax1t plus ax2t plus b. Therefore, it is not equal to y1t plus y2t. Why? Because y1t plus y2t will be y1t will be ax1t plus b and y2t will be ax2t plus b. That is equal to a x1t plus a x2t plus 2b. Therefore, this is not linear. Hence, the option D is the correct option. Understood? Any doubt in this? If you have any doubt, then you can ask. Hence, the system is non-linear. Just what we have done, we have just checked the first additive property, because if a system is linear, then it should satisfy both additivity and homogeneity. So we have just taken the input xt is equal to x1t plus x2t, this, and we have checked whether the output is y1t plus y2t or not. But in this case, it was not. That's why the system is non-linear. Any doubt here? Okay, so now we will see one another important property, that is time variant and time invariant system. Time variant and time invariant system. So the system is time invariant if its input output characteristics does not change with time. Okay, so what does it mean? Like, let's suppose there is a system here as, when input is given, that is xt, xt input is given and output produced is yt. Okay, now when the input is shifted by like t naught, like the input is delayed by t naught, then it will be x t minus t naught. Then our output will be also delayed by y t minus t naught. So if delayed input xt minus t naught produces a delayed output yt minus t naught in this case, then the system is said to be time invariant. Okay, let's write this point. If its input output characteristics does not change with time. Any doubt in this? Means if delayed input xt minus t naught produces delayed output yt minus t naught, then the system is said to be time invariant. Now we'll see some of the examples. Let's take example. Determine whether following systems are time variant or time invariant. Okay, so we'll take some examples. Till now, if you have any doubt, then you can ask. Any doubt till now here? So the first example is yt is equal to txt, and let's take second one. Yt is equal to x2t, and let's take one more example, that is yt is equal to x minus t. Now we have to check whether the following systems are time variant or time invariant. Okay, how we will check? We will just give the input, like delayed input we will give, that is instead of t we will substitute t minus t naught, and we will check if output is also delayed by same unit, then it is invariant, that is time invariant system. So the first one, that is yt is equal to txt. Now let delay input by t naught, delay input by t naught. What we will get? Y1 t is equal to tx t minus t naught. See, here we have just delayed the input by t naught. This means only like the input function which is depending on t, that will be changes by t minus t naught. Okay. Here just we have to substitute xt. In xt we have to substitute xt minus t naught. Okay. Now delay output by t naught. This means y t minus t naught, that is y2t. This will be equal to t minus t naught into x t minus t naught. So this is clearly not is equal to y1t. Hence this is a time variant system. Any doubt in this? Any doubt? Then you can ask. Like see, first what we have done, just we have uh, first thing what we have to do, we have to just substitute xt as xt minus t naught. Second, we have to substitute yt as yt minus t naught. Okay. So in this we will get y1t, in this we will get y2t. If y1t is equal to y2t, this means it is time invariant. If not, then it is time variant system. Okay. Now let's take the another example, that is yt is equal to x2t. Again, first what we will do, we will shift xt to xt minus t naught. So what we will get? Y1t is equal to x of 2, and there t will be shifted by t minus t naught. Now this was delaying input by t naught. Now delay output by t naught. Then we'll get y2t, that is equal to y of t minus t naught, that is equal to x of, in place of t you just substitute t minus t naught. Then you will get x of 2t minus 2t naught. See, delaying input by t naught, this means just we have to add this extra minus t naught, okay? So here we will adding minus t naught, but this y1t is not equal to this y2t. This means it is again time variant system. Any doubt in this? If you have any doubt, then you can ask now. Okay, so the third one you can solve by yourself. That is yt is equal to x minus t. That is also a time variant system. Okay, I've just given a hint. So now we will move on to the causal system and non-causal system. And after this, we can solve a few gate examples. I will take out the gate book and we'll see some of the important questions. This thing you have already studied in the week 2 lecture, but just for like revision, I'm just teaching. So a causal system, like if the response, like if the output response depends on the present input, past inputs, but not on the future inputs, then it is called as a causal system. Okay, so just write this definition. Depends on present and past inputs, but not on future input. Non-causal system also depends on the future input. So here we can write it as yt is equal to, let's suppose, is a function of either xt. If yt is a function of either xt or xt minus t naught. This means yt is depending on the present and past input only. Here t naught is greater than 0. Then it is a causal system. Okay. But yt should not like does not depends on the function of t plus t naught. Okay. So this is causal system. Any doubt here? So now we'll take some example and tell me whether the system is causal or not. Okay. Causal system or non-causal system. The first one is yt is equal to integration of minus infinite to t x tau d tau. Can you tell me what is this? This is causal system or non-causal system? You can chat means comment in the chat box also if you are not comfortable in speaking up. The second is the limit of integration is changed from minus infinite to t plus 2 x tau d tau. And the third one is yt is equal to minus infinite to 2t external data. Can you please tell me whether the system is causal system or non-causal system? So here you can see you have to check whether the system depends on past and present input or it depends on the future input. If it depends only on past and present input, then it is a causal system. If it depends on future input, then system is non-causal. So in the first you can see output yt depends on minus infinite to t. Okay. So this is present and past. So this is a causal system. Now in second example you see this t plus 1, t plus 2, these are the future input. Hence the output depends on the future input, therefore it is a non-causal system. And again here 2t, let's suppose t is equal to 2, then 2t is equal to 4. Then again it depends on the future input, hence the system is non-causal system. Understood? Any doubt? Any doubt in this? Okay. So now we'll see very important, that is a stable and unstable system. See, today we are just solving examples based on the different types of systems. So we have seen first linear and non-linear, after that time variant and time invariant, after that causal and non-causal. Now we will see a stable and unstable system. Let's suppose like input is bounded. Let's suppose in a system we give an input that is bounded by some c, let's suppose. That c is less than infinite because it is a bounded in for all t. Then, and after that, yt, that output is also bounded by some constant k for all t. Then the system is said to be stable. And this kind of stability is known as bounded input and bounded output. So, BIBO system are those, means let's suppose write like this. If bounded input results in bounded output, then the system is said to be bounded input, bounded output, stable. Okay. So now we'll see some examples. yt is equal to x squared t. Tell me if this is bounded input and bounded output or not, or is this a stable or unstable system? So see, first what we will do for checking a stable or unstability, check stability. First what we'll do, we'll give some bounded input. We'll assume, let's suppose xt is equal to ut. Ut is our unit step function that we have already seen. What is unit step function? 0 for all negative value and 1 for all positive value. So this is our ut. So here xt is equal to in ut, that is a bounded input. Now for the bounded input, we will check what is the output, whether it is bounded or not. So the output will be u squared of t. Okay. So what is u squared of t? That is also ut only. So this is also the bounded output. Thus, bounded input produces bounded output. Hence, the system is stable. Okay. Any doubt in this? Now we'll check one more example. Let yt is equal to differentiation of xt with respect to time t. In this case, again, we will give some bounded input. So we'll give one bounded input, that is xt is equal to ut. Okay. Now yt is equal to differentiation of xt. Here xt is given as ut. We know that unit step function, like differentiation of unit step function, is impulse response. Impulse function, that is, here you can see, this is our unit step function. This I have already taught in the last lecture. If you have any doubt, you can visit there. This is our unit step function. Now, when you will differentiate it, what you will get? You will get an impulse function like this. At t is equal to 0, the value is not defined, that is infinite, and for all other value of t, it will be 0. Hence, this is not bounded. Okay? Therefore, the system is unstable. Understood? Any doubt in this? Now there are different like invertible and non-invertible systems. Those you can just read from the सानू क्लास चल रहा है सानू क्लास. So now we will see linear time invariant system, like the combination of two different kind of system, and we'll solve lots of very good examples that is important related to the GATE examination. Okay. Linear time invariant system. This means the system is linear and it is also time invariant also. It have properties that is it should be linear, and linearity depends on two things, that is additivity and homogeneity. And it should be time invariant. Time invariant means a delayed input will give the delayed output, then it is a time invariant. Now we'll see continuous time LTI system. From here only the concept of convolution came. In this, before that we'll see like when an impulse response is given to any system, then the output is st. Okay, that is the impulse response. Like when the input is given del t, then the response of that input is impulse response, that is ht. Okay, now when xt is given to that system, then our output yt will be transformation of xt. If we give xt is equal to del t, that is the impulse function, then our yt is equal to ht, as we have seen in the first case here, that is the transformation of impulse function. Okay, now we will use shifting property. Like any signal can be produced as a combination of weighted and shifted impulse. Like we know that we have already studied in the last lecture that any function xt is given as x tau del t minus tau del tau. Okay, so this is a shifting property of impulse function. Now our xt is equal to this, then yt is equal to transformation of xt. So this will be minus infinite to infinite. Now what is, see x, we will just do the transformation of this whole equation because this is our transformation of xt. So here we will get transformation of del t minus tau d tau. So yt is equal to minus infinite to infinite x tau, and this transformation of del t minus tau will be h t minus tau, because transformation of del t is equal to ht. So the transformation of del t minus tau is equal to h t minus tau. Understood? If you have any doubt, then you can ask here. Let me check whether the video is recording or not. Yeah, it is recording. If no doubt, then we can proceed. And also this integral, this is very, very important, and this is also known as the convolution integral. This is known as convolution integral. So how it is represented? It is represented as yt is equal to xt convolution ht. This means this is equal to integration minus infinite to infinite x tau into h t minus tau d tau. Okay, so this is very very important in the whole signal and system. Now we will study about the convolution will come everywhere, and even this is important in the communication system as well. So now we will perform this convolution operation and we'll solve few examples. So let's suppose find the convolution of two signals given below. So the first signal that is given as, that is ht. This is the second signal that is given as xt. Like this. Now we have to find the convolution of these two. And we also know that xt convolution ht is that is equal to ht convolution xt. This you have already studied in the week 2 lecture in the NPTEL. This is a commutative property of convolution. Okay. So there are different steps like this one question I will solve, remaining you can solve here. We know that convolution yt is equal to xt convolution ht, that is equal to integration minus infinite to infinite x tau h t minus tau del tau. So first what we will do, we will just uh, convert this ht into ht minus tau. Okay, so we will convert this ht into ht minus tau and xt as the x tau, and then we'll multiply it and integrate it to get the convolution. So the steps involved are, there are two methods. Either you can directly solve using the analytical method, like using mathematical formula, and second is the graphical method. So today we will solve this question by graphical method so that you will get what is happening exactly. So in this, the first step is, get the limits of y. Obtain the limits of output yt. So sum of lower limits, like the output, the limit of yt is sum of the lower limit up to the sum of upper limits. So now The limit, what will be the limit of output? So limits at output in this question, you can see sum of lower limit. So lower limit here is 0, here it is 1. So that will be 0 plus 1 is less than equal to t is less than equal to sum of upper limit, that is 1 plus 3. So that is t is greater than 1, greater than equal to 1 and less than equal to 4. So this is the limit of output. This is the first step we have to find. Okay. Now in the second step, this was the step 1. Step 2, what we have to do, change the axis from t to tau. Change the axis from t to tau. Why we are doing this? Because in the definition of convolution, you can see here, this is x tau and s t minus tau. So we'll get now, when you change the axis h tau, then the x-axis will be tau. Okay. So here ht is this, then h tau will be same only, but the axis name will change. This is from 0 to 1. Now here this will be from 1, 2, 3. This is our x tau. That is same only. We have just changed the name t from the tau. So that we can do all this transformation on tau. That is x tau and s t minus tau. Now what we will do, we will find h minus tau. So this will be the mirror image along the y-axis. Okay. Mirror image along y-axis. So our h minus tau will be mirror along the y-axis. So it will be like this. I will draw it neatly. So this is 2, this is 1. This is from 0 to minus 1 because this is h minus tau. Okay. Now if you will shift it, like we have to find h t minus tau. So we have to shift it by t unit. So h t minus tau will be shifted to t unit here. So here it will be minus 1 plus t, that is equal to t minus 1. So we have got this ht minus tau. Now what we will do, we will do the multiplication. So this was our step 3 and this was our step 4. I will just cut it. This is our step 4. Now step 5 is, so step 3 is known as folding, that is just a mirror image along y-axis, and step 4 is just the shifting by t. Now what we will do, we have to multiply x tau into ht minus tau. Okay. So step 5 is multiplication. So here we will see this is like little see this graphical things when you will enjoy it if you solve it by your own. Yeah, it is taking time, but in examination you need not solve by graphical like slowly. You can solve it very fast way also. But we will solve it here step by step. So now on the same axis we will draw here x tau and ht minus tau both. So this is our ht minus tau that is equal to t minus 1. This is 2, this is 1. And here this is our xt that is 1, 2, 3 and this is 1. So now when t is less than 1 like here for and what is the limit of t we have found that is 1 to 4 okay. So for t that is less than 0 to 1 if you multiply h this is our ht minus tau and this is x tau. So that ht minus tau into multiplied x tau is equal to 0. Therefore, yt is equal to xt convolution ht that is equal to 0. Understood? Now we will shift value of t from 1 to 2. Okay? For t is equal means t is greater than 1 and less than 2. In this case, what it will happen? Now, if t is 1 to 2, this means this t minus 1 will lie from 0 to 1. Okay? And this t will lie from between 1 to 2. So, somewhere you will get like this. Then t minus 1 will lie between 0 to 1 and t will lie between 1 to 2. So here you will get yt is equal to xt convolution ht that is equal to 1 to t x tau h t minus tau delta. So x tau and h t minus tau what it will happen like when you multiply it. So these are the overlapping area. Okay. So this will be 1 into 2. Okay. So this is 1 and here it is 2. So this will be equal to 1 into 2. And what is the limit of this t? T is from this 1 to t. Okay. And that is here delta. So we will get 2 tau and tau limit is from 1 to t. So it will be 2 into t minus 1. Understood this? This is very important. If you understand this, then you will understand all other further process. Okay. So we will now take t as for t is between 2 to 3. Now when t is between 2 to 3, So our x tau is fixed. That is 1, 2, 3, and this is 1. Now here t minus 1 will be between from 1 to 2. So somewhere it will start from here. It will go between 2 to 3 because our t is 2 to 3. So this point is t minus 1, this point is t. So now the overlapping area is given as this one. So this is from t minus 1 to t. Okay. So yt is equal to from t minus 1 to t 1 into 2 delta. So if someone joining late, there is no problem. These lectures will be uploaded on YouTube and link will be shared in the NPTEL portal. So here the overlapping area is between t minus 1 to t. Okay, the limit of the integration. It will be, this is 1 and this is 2. So 1 into 2 delta. So we will get 2 tau, and tau is from t minus 1 to t. So is equal to 2 t minus t plus 1. So this value is equal to 2. Now we will again take for value of t between 3 to 4. If we take the value of t between 3 to 4, our x tau will be same, that is 1, 2 and 3. This is 1. Now ht minus tau, how it will change? The limit is t minus 1. So t is 3 to 4. So it will be between 2 to 3. So it will be here, somewhere between here. So this is our t minus 1 and t is between 3 to 4. Let's suppose this is 4. This is 2. Now the overlapping area is this. The limit is from t minus 1 to 3. So yt is equal to t minus 1 to 3, 1 into 2, because xt minus tau is 1 and ht minus tau is 2 del tau. So it will be 2 tau, and tau is varying from t minus 1 to 3. It will be 2, 3 minus t plus 1. So it will be 4 into 2, 8 minus 2t. Now when you go beyond, like t is greater than 4, there is no overlapping area. You can check this. So yt is equal to 0. Because our limit of t we have already calculated here in the step 1, that is from 1 to 4 only. So after 4 there is no overlapping area. So our yt equal to 0. So now we will summarize our yt. Hence yt is equal to 0 for t is less than 1. Here you can see for t 0 to 1 output is 0. For t 1 to 2 our output is 2t minus 1. So for this output is 2 into t minus 1, and it is 2 for when the t is between 2 to 3. Okay, and it is 8 minus 2t when t is between 3 to 4, and it is 0 again when t is greater than 4. Here you can see for t is 3 to 4, for t is 3 to 4 our value is 8 minus 2t, and for t is between 2 to 3 our value is equal to 2. Understood? So this is the convolution using the graphical method, and in future we will solve using the analytical method also. So just one more example I am giving. This is just for your homework. You can try this. Now, this is the homework question. If you have any doubt, then you can ask me in the next lecture also. Find the response of two, find the response of continuous time LTI system with input xt and impulse response ht given below. So again, the st xt are given below. You have to just find the convolution of ht convolution with xt, and you will get yt. That is the output. So you can do using the same method how we have solved before. So this is our xt. Xt is 5 for the value of t from 0 to 2, and ht is 10 for value of t from 0 to 2. Okay, so just using the how we have solved the previous question, just solve this, you will get the convolution and the output yt. So we will solve one more question because this is tutorial session, so we will focus more on solving question, and we'll also see the theoretical concept as we already studied in the first half of the lecture. So this is find the response of a continuous time LTI system with input xt and impulse response ht as shown below. Again, we will solve this question using graphical method. If you have any doubt in the last question, then please ask me. Just wait for a minute. I will switch on the light. In this question, our xt is given as e के power minus at ut. The maximum value of e to the power minus at ut will be 1 at t is equal to 0. And ht is given as 1. That is unit step function. So what are the step 1? First, step 1, what we will do? Find the limit of y. So limit of output is equal to, lower limit is 0 plus 0 and upper limit is infinite plus infinite, that is infinite. Okay, now step 2, in this we have to change the axis from t to tau. So when you change the axis from t to tau, you will get like this x tau, and the x-axis will be tau. This is 1 e to the power minus a tau u tau. Okay. Now the third step was the folding step. In that we have to find h minus tau. So that will be the mirror image along the y-axis. So it will be like this. Okay. Now the step 4 is the shifting, that we have to find h t minus tau. We have to shift the h minus tau by t units. So when you shift it by t units, you will get like this. Because it was starting from 0, so now it will shift by t units. Okay. So ht minus tau will be like this. Now we will multiply x tau into ht minus tau. That is the step 5. So we'll take different case when t is less than 0. Then our ht minus tau will be like this because t is negative, and x tau will be, this is x tau, that is equal to e to the power minus a tau u tau. So there is no area overlapping, therefore yt is equal to 0. Now for t is greater than equal to 0, this is our x tau, and this is our h t minus tau. Here t is greater than 0. Okay. So the overlapping areas are this, that is between 0 to t. So yt is equal to, by the convolution formula, it will be 0 to t x tau h t minus tau del tau. So between 0 to t, x tau is e to the power minus a tau into, and h t minus tau is 1. So the integration will be minus 1 by a e to the power minus a tau, and here tau is from 0 to t, so it will be minus 1 by a e to the power minus at plus 1. So yt is equal to 1 minus 1 by a e to the power minus at. Sorry, this will be 1 by a. So what will be our output? Yt is equal to 0 when t is less than 0, because there is no overlapping area here when t is less than 0, and yt is equal to 1 minus e to the power minus at by a when t is greater than equal to 0. Any doubt in this question? See how easily we can solve these kind of questions. If you have any doubt, then you can ask. And you have already studied that the convolution is commutative, distributive, and associative. Means it obey the commutative rule, distributive rule, and associative rule. So we'll see these five properties of convolution. There are seven properties of convolution. We can see this proof you can see in the later on exercise. So before that, we can solve one more question that is totally based on the mathematics method. So the next question is, find the convolution of two continuous time signals that is given as xt is equal to e to the power minus t into ut and ht is equal to e to the power minus 2t into ut. So how we will find? We will find directly this time using the analytical method, that is the mathematical formula. So the formula of convolution is minus infinite to infinite x tau h t minus tau del tau. Okay, here you will get minus infinite to infinite. X tau is minus e to the power minus tau u tau, and h t minus tau, what it will be? It will be e to the power minus 2 t minus tau into u t minus tau del tau. So here, now this equation will be from 0 to, like, see, uh, u tau is, this is the graph of u tau, and this is the graph of u t minus tau. That will be, okay. So when you multiply these two, the overlapping area is between 0 to t only. So 0 to t e to the power minus tau into e to the power minus 2 t minus tau del tau. So after that you will get uh, the integration is with respect to tau. So the terms with respect to t will come out. So e to the power minus 2t 0 to t e to the power minus tau plus 2 tau d tau, that is equal to e to the power minus 2t 0 to t e to the power tau del tau. So you will get it as e to the power minus 2t into e tau. So that is equal to, so this will be e to the power minus t minus e to the power minus 2 tau. Okay. And for t is greater than or equal to 0. And when t is less than 0, then yt is equal to 0 because the integration limit is always 0. So yt is equal to 0 for t is less than 0. So what will be the final value of yt? Yt is equal to e to the power minus t minus e to the power minus 2t. So you will directly write unit step function because yt is only defined from 0 to infinite. Okay, any doubt in this question? Then you can ask. Okay, so now we will see some of the properties. The proof you can check on internet you will get, because if you will take proof then it will take 1 or 2 more hours. So if you want me to prove then I can prove, but it will take lots of time. So properties of continuous time convolution. We will see various properties. First one, that is commutative. In this, xt convolution ht, that is equal to ht convolution xt. So this is the commutative property of convolution signal. Okay, we can prove this as well. Like, let's take xt convolution ht, that is given as, the formula is minus infinite to infinite x tau h t minus tau delta. So what we'll do, we'll take t minus tau as z, thus tau is equal to t minus z, therefore del tau is equal to minus of del z. So now substitute this in the above equation, we'll get minus infinite, like, now we will substitute. So we have to substitute here z is equal to t minus tau. Okay, so when tau is minus infinite, so z will be t minus minus infinite, that is equal to t plus infinite. So it will be plus infinite and it will become minus infinite. And tau is equal to t minus z, and ht minus tau is equal to hz, and del tau is minus del z. So now you can see here there is a minus sign. So this minus sign can be removed when you just flip the lower and upper limit. So it will be minus infinite to plus infinite x t minus z hz dz. So this can be written as hz into x t minus z dz. Now when you equate these two, see, when it is written as x tau ht minus tau, then we write it as xt convolution ht. Here it is written hz into xt minus z. So what we can write? This is ht convolution xt. Okay. Hence, xt convolution ht is equal to ht convolution of xt. So this is the commutative property of convolution. So from now we will not see the proof. We will directly see like what are the other properties. The second one is distributive property. In distributive property, it is given as xt convolution h1t plus h2t. In last class, I was solving this example, but okay, we'll solve this in the next class. This can be written as xt convolution h1t plus xt convolution h2t. You can prove this also. Let's suppose this is a very easy proof, so I will do it, since it is very less time taking. All proofs are easy only. So xt convolution h1t plus h2t, that can be given as minus infinite to infinite x tau into h1 t minus tau plus h2 t minus tau del tau. So we can write it as minus infinite to infinite x tau h1 t minus tau del tau plus minus infinite to infinite x tau h2 t minus tau del tau. So this is simply xt convolution h1t plus xt convolution h2t. Okay. So this is the distributive property of convolution. Now we'll see other properties also. That is the third one. That is associative property. We will see the seventh property. After that, today we will finish the lecture here. So xt convolution h1t convolution h2t. This is equal to xt convolution with h1t, and after that the whole is convolved with h2t. You can easily prove it. Just substitute the formula. You can easily prove it. Okay. We'll not see the proof of this one. We'll see the proof of the important one. Now the fourth property, that is convolution with an impulse. This means xt convolution del t, that is impulse function, is the function itself. Whenever a function is convolved with del t, it will give the same function. So we'll see the proof, because this is really interesting property and this is very useful also. So xt convolution with del t is given as minus infinite to infinite x tau del t minus tau del. So from the sampling property of unit impulse, what we have studied in the last lecture, xt into del t minus tau is given as x tau del t minus tau. This we know, that is the sampling property of impulse function. Xt del t minus tau is equal to x tau del t minus tau. So we can write xt convolution of del t, that is equal to x tau del t minus tau, we can write it as xt into del t minus tau. So it will be xt into del of t minus tau del tau. And this integration is with respect to tau. So we'll take the term of t outside. So it will be xt minus infinite to infinite del t minus tau del tau. Now the integration of this from minus infinite to infinite will be 1. So it will be xt. Therefore, xt convolution del t is equal to xt itself. Okay, this was the fourth property of convolution. Now the fifth one, that is time shift property. In time shift property, when xt is convolved with ht. Let's suppose this gives us yt. Then xt convolution with ht minus t naught. It will give yt minus t. And this is also equal to xt minus t naught convolved with ht. This is also equal to yt minus t naught. Or in better way, we can write xt minus t1 when convolved with ht minus t2, then it will give it as yt minus t1 minus t2. Understood? So this you remember. This is very important. So just keep the note point here, like when xt convolved with del t minus t naught, we will get it as x t minus t naught. And when x t minus t naught convolved with del t minus t1, then using the above formula, what it will be? It will be x t minus t naught minus t. Okay, understood? These are very simple. Now we'll see two more properties. And after that, today's topic will be over. Property number 6, that is differentiation property. So in this, we'll see convolution with respect to the differentiation. When xt is convolved with ht, it will give it as yt. And when you differentiate xt with respect to t, and then you convolve, you will get dyt by dt. I will suggest all of you to see the live lecture in live way only so that you can ask doubt. If you see the recorded one again, then it will be like if you will face any difficulty, you won't be able to ask me in YouTube. So like every Monday, 5 to 7, I will be live. So join that time. Link is shared on your mail ID. And also if xt is convolved with differentiation of ht with respect to dt, that is equal to del yt by del t. And let's suppose if both the xt and st is differentiated and convolved, then what will be the output? It will be del square of yt by del t square. So the generalized form is generalized for nth differentiation. The order will add up like del differentiation of yt n times with respect to t is equal to dmxt by dtm convolution drht dt to the power r, where this m plus r will be equal to n. Okay, the order is adding up here. Proof is very easy. We can see Yt is given as the convolution of xt ht, that is equal to minus infinite to infinite x tau h of t minus tau. Okay. So differentiating with respect to t, what we will get? Del of yt by dt, that is equal to minus infinite to infinite x tau. See, t tau is independent of t, so differentiation will happening at the ht minus tau only. Now this differentiation and integration, so this will become xt convolution with d of dt ht. Okay. Now we will see the last, that is the time scaling property, that is the seventh property. And we'll solve one or two questions. After that, we'll finish it off this lecture at 7 p.m. In time scaling property, xat is convolved with hat, then it will be 1 by a mod a, that is the magnitude of a, into y of at. We will see the proof for this because this is important. When you convolve xat with hat, we can write the formula as h of at minus tau del tau. So this will be minus infinite to infinite x a tau into h of at minus a tau del tau. So now let assume here a tau is equal to z. Thus a of del tau is equal to a of, sorry, that is dz only. When you differentiate both sides, when you take a tau is equal to z, and when you differentiate both sides, you will get a del tau is equal to dz. Now substitute this here, you will get minus infinite to infinite xz h of at minus z dz by a. So this is equal to 1 by a into y of at. Okay. So a may be positive or negative here. You can see this can be written as y of at. Okay. So a can be positive or negative. So general expression is given as xat convolution with hat is equal to 1 by mod a y of at. Similarly, let's suppose a is minus 1. So x of minus t convolved with h of minus t, what it will be? A is minus 1, so mod of minus 1 is 1. So this will be simply y of a is minus 1 is minus t. Understood? Very simple question. Now we will see the convolution of two, like general convolution of two rectangular pulses. So like convolution of two rectangular pulses with equal width. Because this is very common in GATE examination, so we have to see this. Convolution of two rectangular pulses with equal width. Okay. Let's suppose the two pulses are given as like this. This is very important because this will take very less amount of time and it will save lots of time in the GATE examination. Let's suppose a pulse is given from T1 to T2. Its amplitude is A1. Another pulse is given, that is X2T, that is again from T3 to T4. Here this is A2. Or let's suppose, let's write the topic as convolution of two rectangular pulses, because if the width is not same, then what we will do? So the convolution results in, this convolution will results in, very easily we can find this. The lower limit is T1 plus T3, that is summation of both the lower limit, and it is a rectangular pulse. The slope of the rectangular pulse m is equal to a1 into a2. Okay, and this upper limit is t2 plus t4, and the slope is here m is equal to minus of a1 into a2. So this is the result of x1t convolution with x2t. Okay. So this is for when the equal width. We'll see for unequal width also what will be the value. This is for equal width. This means T1, T2 minus T1 is equal to T4 minus T3. This is given. Now we will see for unequal width. Convolution of two rectangular pulses with unequal width. If you have any doubt, like if you are watching this lecture in YouTube, then you can ask in the comment section of the YouTube. There I will reply. So let's suppose two function is given. This is minus T1 to T2. The amplitude is A1. This is convolved with minus T3 to T4. Amplitude is A2. Okay. So the output will be trapezium. How it will follow? The lower limit will be addition of both the lower limit, that is minus T1 minus T3. It will go, the slope will be m is equal to A1 into A2. After that, it will become constant. And then here the slope will be m is equal to minus a1 into a2, and the upper limit will be the summation of upper limit of both the signal, that is t2 plus t4. The convolution of any two rectangular pulses having unequal width will always result in a trapezoidal pulse. Okay, whose width is equal to the sum of width of individual rectangular pulses for resulting trapezoidal pulse. The width of rising arm as well as the width of falling arm are equal and equal to the smaller width pulse. Okay, and the slope of rising arm is equal to the product of the individual amplitude of the rectangular pulse being conformed. Just write this point. This is very important point. Notes points. Convolution of any two rectangular pulses having unequal width always results in trapezoidal signal or trapezoidal pulse. The width of output is equal to sum of width of individual rectangular pulse. The width of rising arm as well as width of falling arm of trapezoidal signal are equal and equal to a smaller width pulse. This is very important point. And the fourth point you have to remember, the slope of rising arm is equal to product of the individual amplitude of rectangular pulse being convolved. Pulse being convolved. Understood? And this width is equal to the width of a smaller width pulse. Okay, this means either it will be T2 plus T1 or T4 plus T3, whatever is smaller, that will be the width. So now we will see few question, like let's suppose solve one question based on this. But xt is from minus t to plus t. Amplitude is a1. This is x1t. Okay. And this is convolved with minus t to t a2. Okay. So now the width is same. So this will result in the triangular signal, triangular pulse. And what will be the output? The lower limit will be minus t, that is minus 2t. The slope will be a1 into a2. So if it is raised from minus 2t to 0 and the slope is a1 a2, the maximum peak value will be 2t into a1 into a2. Okay. And when it will decrease, the upper limit will be summation of the upper limit of both the pulse, that is 2t. So any doubt in this? Okay, I guess there is no doubt. Then we will solve the last question for the today's lecture. That is, this was for the equal width, like both the pulse have equal width. Now, if both the pulse have unequal width, like let's suppose this is our xt. xt, the amplitude is this time a1 and width is from 0 to t1. This is convolved with another function ht. The amplitude of ht is a2 and the width is t2. So now the unequal width pulse will result into trapezoidal. We know this. And what are the steps to solve? First, the lower limit is 0 plus 0, that is 0. And here it is given that T1 is less than T2. So the rising arm will be the lower width of both the pulses. So which one is lower? That is T1. So this will be T1 and this value will be T1 into A1 into A2. It will again go constant and the upper limit is T1 plus T2. And this width is again T1, so this will be our T2. Then only it will become T1 plus T2. Okay. So this is the convolution. If you have any doubt, then you can ask and you can see this lecture on YouTube as well. This will be uploaded. The link will be shared in the NPTEL portal and the presentation will be also uploaded. And if you have any doubt now also you can ask. And every week the lecture will be conducted at 5 p.m. between 5 p.m. to 7 p.m. on Monday from my side. So you can attend every Monday. So thank you everyone for attending today's lecture. Today we will finish it off here only. Thank you everyone.